All right, this is the lab and class database presentation by Porter, Faisal, and Peter. So our project was for the IT lab and class support department headed by Ulrich. Our motivation is that the IT lab and class support staff are tasked with managing close to 1,000 electronic assets within labs and classrooms around campus. Machines on campus are generally leased and need to be returned to the manufacturer every 4 years. In order to operate efficiently, lab and class department requires detailed record keeping of assets. One thing they wanted to do was to have the ability to guide guests and staff to resources around campus. This project had many goals, some of which were to create a web application with a back-end database to assist the lab and class department in keeping records of assets. Locating assets, replacing assets, managing software on computer assets, maintaining assets, returning assets to the manufacturer are all included, as well as allowing guests to search for local electronic assets around campus and interact via an interactive map that will guide them to the correct building. Our project has many features. Feature 1 is to track computers, printers, projectors, monitors, and software on SOU's campus. Able to do this, we need to have the ability to add equipment, software, and buildings to the database, edit equipment, software, and buildings. That involves moving equipment between rooms and or buildings, adding and removing software on computers, recording maintenance performed on equipment such as projectors and hours on bulbs in projectors. They also require the ability to search by equipment type, software name, lease year, and location, as well as removing equipment from the database.
For additional features, we needed to make sure that for feature 2, the lab and class staff could very easily pick up and use this as quickly as possible and teach their employees how to use it. So we had to make it as user-friendly as possible to add, edit, and display anything along with deleting it. We had to figure out a way to display building location on an interactive map based on a search criteria for that building. And we had to provide a student/non-IT version of the website so that students and staff can use it to find software they need. To begin our demo, I'm going to bring Faisal on over. After I sign him in using OAuth for our security to redirect and keep people off the site where we do not want them.
So let's go to the guest page. So our client was eager to provide a friendly user experience for the student and the faculty. So once the student or the faculty is on the landing page, and you would see the two buttons, one for building and one for software. And if you have no idea, you would go scroll down. It would see a description of what each button would do. So let's go. I want to find specific software and specific building. I would click for search for software. Then let's say I want to search for body. The optional filter, the building filter is optional. So I'm gonna choose science building and click search. It would show me the software name and the building name along with the room number. And if I click on the science building, it would take me to the SOU map. Now let's say I want to find all the software that exists in that building. I would go search by software, then scroll down, and let's see, say science building. Click search. I would see all the software that exists in that building with the room number, as well as the map that takes you to that building. And now for the admin page with Porter.
So for the admin page, we'll need to be able to control everything you can see on that side. So let's start by adding equipment and showing you what that would look like. First, we can search just by clicking search, where we can see everything here from their serial number, name, type, model, lease year, building name, room number, and edit and delete. Let's just simply add a piece of equipment. Let's put 49 so we know exactly which one it is. Name it test. We'll make up a model and say MacBook Pro 2. Year 4, 201, inside of the bookstore, and we can decide on a type of laptop, desktop, or possibly add a new one. Let's go with laptop. You can see a very dark message that says it was successfully completed. Click search, and we have it all poured out again. let's find that name now. Test. You can see we have multiple tests here from earlier. Right here, let's try editing it to see what happens. We're unable to edit serial numbers, but we can simply change the name to test2 to better differentiate it. Update, then come up here, type in test2, and click search. You can see it appears right there, then we can delete it. We would also be able to move its rooms by clicking a few buttons right here and here, choosing a building, and then typing in the room number. As you can see, those were moved successfully. Now let's go back home and look at software, where we can see we can search software like that, search by a category or a search bar, and when we add or edit software, we can give it a name and then select a category or even add a new one. We can click right here to edit it and choose a new category or update the name similar to how we did inside of equipment. Now from equipment, we can access the maintenance page, by clicking a serial number not already in it, and if it's not found in there, it'll ask you to add a new note. Let's go look inside of there to see what is in there. Right now, you can see that there's already a note in there for this serial number, and if we click on it, we can add new entries to that serial number. We can also sort by latest, oldest, ascending serial number, or descending serial number. Now, to show off bulk add, it is a simple CSV file. You can click download this template, and it will give you a template that you can fill out to put as many pieces of equipment as you would like into it, upload, and then give you custom error codes inside of both the page itself and on the actual CSV file, and allow you to download a fixing file so you can go through and fix each row individually until they are all able to be put into the system. Now, to show off installing software, I'm bringing back Faisal to show you that.
Let's assume that we got a new piece of equipment, either a laptop or a PC, and we want to install the software as needed. So let's search by the serial number. Click search, and as we can see, there is no installed software in it. So I'm gonna click the manage software, and I can add all the software as needed to that associated equipment. And then I can also remove if there is any. So let's just execute the command, search again, and as we can see, all the installed software that we just added.
Now, to show off how we handle admin management and accessibility. Using OAuth 2 in our database, we mark super users who are the only people able to access this page, and as you can see, all of which have to be SOU email address. Here we can add new users by clicking add user, enter their username, and then click this box whether we want them to be a super admin or not. We can do the same if we decide to promote someone to super admin by simply editing and clicking the super admin box and confirming the edit.
So for the tool and technology we have used to achieve this capstone is HTML, which is a hypertext markup language, which is the backbone of any website. We have also utilized CSS, which is basically style sheet language that you use to control the layout of the website as well as the appearance. We have used JavaScript, which is to enhance the overall experience user. We used PHP, which is the intermediate between the back end and the front end, which basically it pulls the data from the back end and display it to the front end. We also use PHP Storm, which is an IDE to create a virtual environment to develop the application or the software. We use MariaDB as our database to control and manage our data.
So for hosting purposes and control purpose, we use Docker for both our connection to the database itself, and the web frontend. For security and redirects, we use Google's OAuth 2 API, which allowed us to not worry about handling passwords and allowed our users not to need to worry about us handling their passwords. We use Visual Studio Code when we jumped over to Docker. For testing, we use Basics CRUD operations of creating, reading, updating, deleting, and testing. For the creating, reading, updating, and deleting, as you saw, we demonstrated they all work. We tested those times and time again. We double checked all the resources on the map to make sure that when we click the button, they would take us to the correct area on the map with the correct directions. we binded and parameterized every query inside of PHP, and then threw SQL injections at it to make sure that we would not lose any data, particularly on the front-facing pages. We tested bulk adding actions through the CSV file addition, as you saw earlier, through the bulk adding, by both providing custom errors for the user and by ourselves trying to break it.
All right, so division of labor. This term, our team is quite unique in the fact that we have 3 members. Most teams usually have 2. We do not have dedicated roles. However, we have fallen into roles where we feel we are best utilized for the project. Porter has been our lead database design. He has assisted with coding, documentation, and review. Faisal has been lead website design, assisting in coding, documentation, and review. I myself, Peter, have been lead communications, coding assistance, documentation assistance, and review assistance. Our project has overcome many challenges, the first being information security. We've been working hand in hand with FSOU infrastructure team as well as the security manager to guarantee best practices and data security have been followed, both while developing and through development of our project. In that sense, we would like to thank Francisco, Web Pages IT, David Racco, security manager, Justin, systems admin, Tim, systems administrator, Steven, systems administrator, the entire lab and class department, and our manager, Maggie, Professor Vanderberg, who will host the server, has been another point of contention for the last quite few months. And working hand in hand with infrastructure, we have decided that they will indeed be able to spin up a Dockerized version of our project.
So the third challenge that we face in this capstone, besides that we don't have any fundamental understanding of how PHP works, is running PHP locally. It was pain. We couldn't figure out how to run it locally. However, our manager, Maggie, suggests that we could use PHP Storm, which is an absolutely amazing software that we developed our project over there.
So as you can see on the right, this was one of the many documents we had to deal with when looking at the data. This is a map of our school's server room and how they were storing computers by mapping it directly into Excel and where they were physically placed in real life. We were able to find better documentation elsewhere, but it took a lot of digging and a lot of hours to find, and it was still filled with garbage data. In order to fix it all, Peter developed a Python script to sort through it exactly how we wanted it to, which would catch any errors and make it look how our bulk addition could take it. Then the bulk addition, with its own built-in errors, were able to be tested from that document, catching any errors that were left over after that Python script.
So we've had several concerns through this project, one of which would be sensitive information concerns. Working with David Racco, our security manager, we have decided that, first of all, serial numbers would want to be obscured. We don't want the guest user page to show serial numbers due to the fact that then anyone could essentially gather serial numbers that are being used around the school and impersonate a manufacturer and use them for phishing attacks. Another issue would be software versions and operating system version. As anyone who has taken security classes knows, some operating systems are vulnerable and some programs are vulnerable. Usually those issues are patched in later versions. However, if you are running an older version, you don't want someone to be able to look up the version number and then try to discover vulnerabilities in that version. In conclusion, we have developed a web application with a back-end database for improved electronic asset management for the IT lab and class support group. In doing so, we have transitioned them from using Excel sheets to a relational database to enhance efficiency, accuracy, and resource accessibility. We have developed a guest interface that allows students to efficiently find and locate software and equipment around campus utilizing the interactive SOU map. We have overcome challenges like data security and integration were addressed, leading to a secure, user-friendly platform. Our efforts have resulted in a simplified process for both staff and students to find and manage electronic assets around campus.